Testing. 1, 2, a Scooby-Doo. Okay. Again, I'm still ill from the last video. Well, not from the last video, but I'm still ill. So I will be taking drinks. You might hear the occasional cough or clear up my throat, but I apologize. But I wanted to get this out before Christmas because, I mean, I'm kind of excited, right? You guys asked for code, so I thought I'd provide the best kind of what I've got at the moment. I mean, it's a mess, but forgive me. So I just wanted to release something. So it's DreamerV2 _realtime. I've gone through it as best I can in terms of installing everything you need. I've only done Windows. I haven't done any other environments. Windows is all I've got. So if you want to install it on Linux or Mac OS or, I don't know, some homebrew installation, then you're probably going to have to do some work for that. I strongly suggest Conda, mostly because of Pywin32, which has an error sometimes where it refuses to install with pip and you have to Conda install it. But these are the libraries that my environment uses. The most notable one being PyTessie, because while PyTesseract is fine, it's very slow. Sorry. It might be okay for 4 FPS, but I don't know how that's going to affect Dreamer's algorithm itself doing stuff. PyTessie is a very, very slimmed down version of PyTesseract, which means it's not as accurate, and you have to take some liberties and do a bit of like, you know, that's close enough to what I'm looking for. Like whenever you see this weird symbol, it means this. But I've got it working. So, you know, I'm only using it for the score, just for getting score. I have done environments where I do something different, but maybe we'll look at that at a later date. Yeah, so it will work with newer versions of Jim, this environment. I have set it up to do that. But I have done some work in Dreamer to remove some of the more Atari stuff, because they're all set up in that same way that DeepMind did everything like 10 years ago, where it's like, you know, assert that it's no frame skip, assert that it's, you know, ale.lives or lives if it's a newer version in the info and things like that. So I've removed all of that. Like that's all done in the environment, whether you like terminate after 1 life lost or whether you go until 0, that's up to you. It's whatever. So that's all been done in the version of Dreamer I've provided. I've done setting up RetroArch, which is what I've called it just because that's what I'm using. I named it that ages ago. I've never bothered to change it. But I manually add it to Jim. You can go through the registration process, but I've no idea if it will work properly. So I haven't bothered trying. I just paste the file in and make the changes to the actual init files myself. Doesn't take much longer. Seems to work fine. It's put in classic control purely because Atari environment's all a bit weird. It is treated as an Atari environment by the Dreamer algorithm, but the actual environment is in the classic control folder. I'm just having a drink like mummy. So don't worry about that. That's just how I've got it to work. So once you've done that, you can install Dreamer2 as if it was their version. You just use the folder that's in this repository. I use Python dream.py, which if I run up and just quickly take a look at, is nothing special. It's just import Jim, import Dreamer, and then this is the kind of edits to the config. So we're doing, what's that? 5e7, so 50 million steps. There's a 50,000 step prefill. That takes a while at this speed. Any other edits I'm just doing to the actual config file itself. Don't ask me why. I should really do it in here. I just haven't. And then Jim is obviously RetroArch, and then you just train like that. It's nice and simple. Feel free to make edits to this. I have left it as the paper suggests. I have not done anything extra compared to what Danny Jar suggests himself. So with some changes, your mileage may vary. You may get better results. I am more than happy. I'd love people to experiment. Maybe there's a better way of doing this. I'm one guy with one computer, so I can't try everything. The most important things if you run into any issues are these. First things first, I'm running a mid-range PC, I would say, but with quite a lot of RAM. I had to lower the amount of the size of the replay. Like they used 2 million steps. I had to drop it down to 1.5 because it was too much for my RAM. But other than that, it's working very well, which is wonderful, honestly. So if you have less, so in terms of the replay capacity, let's just pop open the config file. I'm just going to have another drink. So this is the config file. This line is the most important one, line 23. So if you have a lower spec computer than me, if you've got 16 gig of RAM or 8 gig of RAM, you are going to need to do this. Like mine is 1.5 gigs, uses about 23 gigs of my memory, 22, 23. So if you're using 16 gigs of memory, you might have to drop this down to 1 million. If you've got 8 gig, you're going to have to go lower, and I'm not sure you're going to get the performance. I would be concerned about 1 million. It may not be enough. But if you have 64 gigs of RAM, please up this. It will help dramatically over time. I've only run this for 6 million steps out of the 50 million that it's going to be doing. I've no idea what's going to happen as it gets to the point where the beginning of the level and where the furthest point Mario gets to is longer than the replay. Like, who knows? If that's a point, I don't know if Mario could beat the entire of Super Mario Land in less than 1.5 million steps. Maybe. That would be interesting to find out. I mean, 50 million steps is going to take me an age to do. So we've got time to worry about that. Anyway, so that would be my main troubleshoot, would be computer specs. I wouldn't change anything else. I'd leave everything else as is. I have found that the algorithm simply will not learn. I did 10 million steps without frame throttling RetroArch, and because everything varies, so the number of frames you're going to get in the game is going to vary, and the number of frames that the actual algorithm Dreamer is going to be able to do is going to vary. There's no consistency. Excuse me. I think the main reason why these algorithms, all of these gym-based algorithms, are actually able to learn things like breakout and stuff like that, even lower end algorithms like DQN, is because the emulator only moves when the character moves. Sorry. Oh, this cold is kicking my ass. So, because nothing moves unless an action is taken, there's no disparity between, like when we're playing a game, if we stop for a second, everything keeps moving, unless it's turn-based, obviously. So things like chess is turn-based. You know, none of that really works. None of that's a problem. Go's the same. A lot of the traditional, problems that AI have tried to do, that's been the case. In Montezuma's Revenge, for instance, if the algorithm doesn't make it, it makes no-ops. Like 30 no-ops is often, if they do a random number between 0 and 30 no-ops at the beginning, just as like a make sure everything's loaded kind of thing. That skull at the bottom of the level in Montezuma 1, it's not doing anything. It's frozen because no actions have been made. Whereas with this, that's not the case. Like if I did breakout in real time, if they did 30 no-ops, I don't know how many steps it would be before that ball gets down to the bottom. But that ball's going to be moving even if nothing's happening. Whereas in traditional gym Atari environments, that ball does not move if no ops is made. So yeah, that's kind of one of the things that I've found is that there needs to be some consistency. So that if the algorithm makes a step, then it makes a step, then stops, then makes another step. There's a consistent time gap between those things. Otherwise, the AI can't. It's not going to be able to make that distinction between that time gone, if that makes sense. Anyway, that's kind of where I'm at. In terms of testing, speeding up the emulator, I haven't tested it. I would need better hardware to be able to do that. Mine, I have to restart my whole run because after about 16 hours of running, it will start to dip below 16 frames a second. The actual RetroArch will run at 4 frames a second locked, no problems. But the Dreamer's algorithm will start to drop frames around the 16-hour mark. So I reset it every time, every 12 hours or so, just to be on the safe side, really. But if you have a 3090, a 4090, you might be able to do this at 8 frames a second. And then doubling the emulator speed to 2 times, or maybe even 16 frames a second or 4 times. I don't know. Maybe someone who has better hardware than me could try that. That'd be wonderful. Other games, I'm going to run through my environment now because I really would like to see what people do with this. I know that someone in the Reddit post mentioned that they have been trying to get this to work on another game. So hopefully this will help them. Right, let's have a look at it. So this is, nope, sorry, I ran another algorithm. This is my RetroArch algorithm. So you've got your standard imports. We've got Win32 GUI, we've got PIL, we've got OpenCV, NumPy, Time, not all of these are useful at this point in time, but I haven't tidied it up very well, if I'm honest. So this one is used for Go Explore, which I will explain. In fact, I'm just going to see if I've got... No, I don't. Okay, let's get up the Go Explore one, because that will be huge for a lot of what I'm going to explain. So let's get past it for now, and I'll head back to that code in a bit. So we're using WinCap. This is something I got from CentDex. Thank you so much, CentDex. None of this would be possible without you and Lucas Thompson. Like, you guys from the beginning were instrumental in me getting this environment working. So we capture a dedicated window. I'm not capturing the desktop in a certain, pixel array and having to move my window to the exact right place. This is bang on window capture. So whatever size your window is, this is how it will capture. But it just takes a lot of that trying to get the window in the right place kind of thing. If you stop and start, don't worry about that. You just name your window and you get on with it. And there is a file within here for that. Windows.py. If you run Python windows.py, it will tell you the names of all your open windows. So if you have RetroArch open, you can run this and it will tell you, what name your window is, which is wonderful. You don't have to do all the guesswork. So keys is, again, from CentDex. This is just what keys you're pressing, because we're running this through the keyboard. I did have it working through an Xbox controller emulator, but it stopped working with newer versions of Python, and I haven't had the time to sit down and get it working again. I will, because I want to for newer games. But for now, we're just using the keyboard. And then OCR Reader is PyTessie. We are pushing 5 frames a second because for some reason it drops a frame. It's rock solid at 4 frames a second, but only if I tell it to do 5 frames a second. I don't know why, but it always has to be 1 frame above what you want. So if you want to do 8 frames a second, you need to put 9, 16, you need to put 17, so on and so forth. This is all Go Explore. Don't worry about that. Again, this is Go Explore. We'll talk about that in a bit. So regions of interest, we've got our game over screen. So these are just the particular parts of that window up here, which has like the game over text or the lives. So if I pull open, so if we start, so you've got your lives text, and then let's just speed it up a bit. If we get rid of our lives, you can see the game over. Sorry. So, and then it's just this area here. So it detects that, refreshes. Oh, that didn't mean to do that. It refreshes the window, which is H, and then after I press enter, it resets the environment. Lives are lives. They're just here. And then we have an ROI for detecting start from way back when I was trying to do things a bit differently. And then score numbers is a whole mess because it has to get the screen and then pre-process everything for the OCR to work. And then OCR actually detects it, and then it does a replace characters, which is down here to replace any of the text found with numbers to make certain it's correct. It's all numbers. Weirdly enough, that actually works quite well. It doesn't detect 2s very well. It detects 2s as 7s, but in the overall grand scheme of things, the score numbers are close enough. I mean, yes, they could be better, but it's obviously working well enough for DreamerV2 to learn. Maybe it won't for algorithms that need a bit more return information. Not sure that's necessary. I think I removed it in the version online. Let's use this version actually, just to make sure we're up to date. Yeah, so I put a bit more. Yeah, sorry. Oh, it's cold. I apologize. Yeah, okay, let's use this version because this version is what you're actually going to see. So yeah, I've put a bit more documentation here. Reasons of interest. Yeah, I got rid of that. Okay, so yeah, so we've got our action space, which is discrete 18. This is intentionally the same as the Atari M's in case I wanted to run it through multiple Atari M's before running it through Mario, just see what happened. I never got around to it. This is the exact size of the window that it detects. And then we've got a few of the Go Explore stuff. Seed is required for it to be recognized, isn't it? Yeah, see, ALRNG. This is necessary for it to be recognized as an Atari environment. And then we're on to step. Wonderful, wonderful step. So the beginning of our frame, time detection, observation is when Cab gets a screenshot, we've upped our frames, or so on and so forth. The trajectory is Go Explore. Then we've got to try and accept here because sometimes the score is not detected. And if it isn't, then the whole thing fails. So we have a try. So if it does detect it, great, score is this as a number. If not, it's 0. And then if score is higher than high score, then high score is score and reward is score divided by 100. So just to keep things a bit lower, this is something PPO does. It clips it, but I'm manually doing some of that. I don't want to do all of it. It just keeps the numbers in a manageable size. Counter system. This is credit to Lucas Thompson. I took it from his neat algorithm setup because it's wonderful in terms of, if counter is 1,000, then the game stops early. It means that if Mario's just standing there for 1,000 steps or is running against a pipe for 1,000 steps, then they don't have to go through all the lives and all the time before it stops. It just quicks things up a bit. I think I started this at 100 before, or 200, 250, something like that. It just makes things a bit better. Lives lost. I'm using a number of light pixels. So it detects how many light pixels there are and how many dark pixels there are. And if it's exactly this, it will reset. No, if it's exactly this, then it will reset. That's how I'm detecting lives. I may change that in the future. I have a better way of doing it. It's just a lot more code and requires a lot more organization. Same for game over. So we're looking in that ROI of game over. And if there are exactly this many light and dark pixels or the counter is 1,000, then we're done. No punishment for that because we're done. I don't think there needs to be a punishment. Okay, Go Explore. Now, a lot of people have done novelty in terms of exploration, and I know that the guy that did the Pokemon Red experiments did novelty for his in terms of frame difference. I love the Go Explore idea. I don't like the return because it just saves scumming, really. If we're really brutal, it's save scumming. Basically, they save every new, so every time they see a frame for the first time, or their score is higher than their reward, or equal to, or their trajectory is less than the previous time they got there, they will save the game, and then they will just load the game at the end of 100 steps. Let me show you in the actual code. So in this code, we do 100 steps, and then we break, or terminal, or we just, if we die, we break, or if we do 100 steps of random actions. But in that time, it saves a bunch of values if they're new, or, you know, if certain criteria are met. And then at the end of that, it just restores from random. It's save scumming, let's be real. It works really well in terms of in terms of Montezuma's Revenge. Like, look, you know, 60,000 steps, 70,000 steps, it gets his first 100. Like, by the time it's done 2.5 million, it's got 2,600 points. Like, no other algorithm comes even remotely close to this. But in terms of real games, it doesn't work because, one, RetroArch doesn't support save scumming. You can't have multiple saves that you pick and choose from. So I spent a bit of time trying to get this to work in terms of just running through the trajectory. So instead of loading it from here, it would do a 4i in trajectory. You know, your action becomes whatever I is, and so you just run through each of the steps in trajectory to get back to what would be RAM. And that would work in a deterministic environment, but real-time algorithms are not deterministic. You know, different things happen based on different, you know, environmental factors. So there's an intentional amount of randomness that's put into games to make them more difficult, right? So it might work if the entire algorithm is clocked to a set frame rate. I haven't tried it since I've discovered that you needed frame rate throttling. So maybe I'll try that again, but I'm not too sure that it wouldn't work in something more complicated like Isaac, for instance. In Binding of Isaac, because there's intentional randomization. So the same thing will not happen every single time you load. So it's wonderful, and it's incredibly clever, and it's incredibly simple. But it's, one, not reinforcement learning because it's just using random steps. And two, it's not scalable to real-time environments. So I'm using the frame hashing, the cell hashing, the archive. I'm using all of that because the way it explores and the way it tracks exploration is genius. So I'm able to add a little bit of reward each time one of these criteria are met. Which means that the exploration side of it's very robust and it's very, very clever. And I reset it at the end of every single episode so that every single time that Mario starts the game again, he's in a whole new world. And he has to go back through this. Then we have our actions. These are all direct. So from keys, we've got whenever action is 0, then we release everything just to be on the safe side. Just release everything. Right, left, down, up, X and Z, up and left, up and right. So we've got all of the most important button configurations on a Game Boy console. We don't throw anything into info. It's not necessary. So I have to add it as a blank dictionary or the whole thing fails. And then we have reward. So reward is minus 0.01 because I want Mario to try and do the environment fast. So there's a tiny little negative, which hopefully is designed to encourage speed. And then we times that by 1. just so that it's a way of making sure it is minus 0.01. Then our frame time is calculated, and I've got a print there just for testing, but I print it later on. Then we return everything. So then we reset. First things first, we do self iterations +1, and then we print out what was in the end of this. So in the end of this, we've got our how we're doing, all that kind of stuff, but I've thrown it in here instead. Taken out cells because it's not necessary, because it resets every single time, and then I've added frames in just to keep up to date with things. So then we restart the environment, and then we wait for the load menu, and then we press return, and we start a new game. We reset all of our high scores and counters and all that kind of stuff. We reset our archive trajectory, and we make sure found new cell is false, get a new observation, and return it. Render is pointless, but it's in there because if it's not, Atari will fail. And then get action meaning same for the Atari, but it's also nice to be able to see it, just to be able to know what's what and what's where. But yeah, not sure if Atari needs it, but it's in there. Better safe than sorry. But that's my code. It's not very long, and I could make it shorter if I put proper things in the proper places. Like these don't need to be here. They should be in a function really, because I'm using them multiple times. And they don't necessarily need to be. And I'll get around to that when I do other stuff, other environments. But yeah, so I just wanted to show you the code so that for anyone who wants to add this to change this, you need to find out what your game's called. If you're using a Game Boy game, you don't have to change this at all. You could just put in James Bond or Pokemon or whatever. This will be fine. You just have to set up your retouage properly. Then you will need to make sure your ROIs are correct for whatever you want to do, whether you want to do game overs, track lives, track score, whatever. You need to make sure the action numbers are correct and the size of your window is correct. Then steps are the second most important thing. If you're tracking score, then you probably want to do that. I'd suggest keeping the counter in. I'd suggest dividing by a number, depending on how much score you're giving. If you're just giving 1 or 10, you may not need it. But if it's, hundreds of score or thousands, then I'd suggest dividing it by a number. You've got your game over, go explores all in there, and then your actions. And then whether you want to add in a minus to punishment just to try and keep things going, that's up to you. And then obviously your reset function needs to be in there. But beyond that, adding this to a new game, the hardest part is getting all of the numbers out using like computer vision. But I'd still say it's easier than trying getting out of RAM, because getting it working from a RAM-based point of view is a pain. I can tell you, I tried it. It took me weeks of research. I never want to do it again. I like computer vision more. Even if it's less accurate, I prefer it. It's better. But yeah, so this is the environment. This is how it works. Please go ahead and throw it on other environments. Let me know how it goes. Keep me in the loop. If you have any contributions or suggestions for changes, this is the link. I've added it to my Reddit post. I'll put a link in it in the description of this video with some credits. Please install it. Let me know if there's any issues, and go have fun. Enjoy it. Thank you so much, and I'll hopefully see you in the next one. Probably not till after Christmas now, though. And I might try some new algorithms. I tried curl. It's this one. Works on breakout. Really, really does not work on my environment. It's just not able to do it at all. So if any of you are thinking of using curl, it's not going to work. And bigger, better, faster. Tried that as well. Needs some more work. But I want to try more stuff. I really do. Because maybe there's something out there. I think Dreamer's strength is the fact that it is very good at generalizing environments. Very good. And I think any algorithm that's not is going to really struggle. But we'll see. Anyway, thanks again. I'll see you guys in the next one. Bye now.